In this video, I'm going to model how we use the area model to show long division. So the first thing I'm going to do is I'm going to work with these two polynomials, 3x squared plus 23x plus 19 and 3x plus 2. We're going to show the long division algorithm as well as the area model in order to display how we do this division. So first, I'm going to set up the long division algorithm. Now I want to be clear, it's extremely important that students see this algorithm because as we move forward in mathematics, in both algebraic reasoning and in Algebra 2, students are going to need to be able to use this algorithm because they will be using third degree and fourth degree polynomials in order to do division, which would require an area model that would have a lot of boxes in it and be multifaceted. It would be very difficult to try to use the area model once you get past a certain number of terms. But especially for our students who are they're visual learners, or they struggle in their organization of this division algorithm, it's really important that they have a different model to use. So the first thing that we're going to do to set this model up is we are going to set up our box just like we usually do, and we are going to put our divisor along the vertical axis. You can put it along the horizontal axis. I just chose to put it along the vertical axis. And our first term, our lead term, is going to go in the top left-hand box. Now, if you remember, in our long division algorithm, our first step is to determine how many times 3x, our lead term of our divisor, goes into 3x squared, the lead term of our dividend. So what we do is 3x goes into 3x squared x times. We do the same thing here. If I have 3x on this side of the box and 3x squared on the inside, what term must go here in order for this to be true? Or what do I have to multiply 3x by in order to get 3x squared? And that value is x. Now, in our division algorithm, what happens is I multiply here and I get 3x squared plus 2x. And of course, I put my parentheses around and subtract in order to get to my next step in my algorithm. And so here I get 21x, I drop down, and I have 19. Now in this case, what I'm going to do is I'm going to do the same kind of idea. I'm going to multiply, right? We already multiplied the x by 3x to get our 3x squared. That's where we got our term from. And here I get x times 2, and that gives me 2x. Now, in this next step in our division algorithm, we're looking for how many times 3x goes into, of course, 21x. Interesting here, what I'm looking for is I am looking for how I need to, what value, what term is going to go in my top right-hand box that's going to be added to 2x in order to make my middle term here, my 23x. And there's only one value that can go there, and in that case it's going to be 21x. So in my area model, the question now is, how do I multiply 3x by something? What do I multiply by in order to get 21x? And that thing that I multiply by is 7. Now, over here in my division algorithm, of course, 3x goes into 21x 7 times. And then I multiply and I get 21x and 14, and I'm going to subtract. And in subtracting, I have a positive 5 as my remainder. Now, in the division algorithm, of course, I put that 5 divided by 3x plus 2, and that is my remainder for my division problem. So in this case, I'm going to continue my process of filling out my box, and I have 2 times 7, and that gets me 14. So the question now is, what is missing? What is remaining? And so I can put this together, 3x squared minus 21x, plus 23x, let's try that again, plus 14, and compare that to my original dividend, and see very quickly that there is a 5 that is remaining. And that 5, of course, becomes my remainder over 3x plus 2.